Hey guys, welcome to episode 6 of the series on circles. So, this is the last episode in which I'm going to teach the concepts related to circles. Starting from episode 7, we will be only focusing on solving problems from circles. I'll carefully choose some good problems from circles, and from episode 7, we will solve those problems. In last episode, which is episode 5 of this series, we have solved some problems based on the intersection of circles. Now, in this particular episode, we will be going through these two concepts. The first one being the angle of intersection of circles, and the second one is radical axis. This is the last episode where we'll be going through concepts. Okay. So, the angle of intersection of circles. What is meant by the angle of intersection of circles? Let us say you have two circles C1 and C2, and let us say they intersect at 2 points. So, at any one point of intersection, let us say T1 is the tangent to circle C1 and T2 is the tangent to circle C2. Now, the angle of intersection of circles at this point is nothing but the angle between the two tangents. Here we are denoting the angle by theta. So our goal is to find angle theta. So let us go ahead and derive the expression for theta. So let us say the radius of the first circle is R1 and the radius of second circle is R2. Since this is the radius of the circle and this is the tangent, so this angle is 90 degrees. Alright, and so if this angle is 90 degrees, this total angle is also 90 degrees. Therefore, this particular angle will be 90 minus theta. Alright, I hope this is clear. So this angle is 90 minus theta. Similarly, this angle is 90 degrees and this angle will be 90 minus theta. Now, let us say this point is P, this intersection point is P. Now, consider triangle PC1, C2. So, the total angle C1, P, C2 is simply 90 minus theta plus 90 minus theta. So we are calculating this total angle between these two orange lines. So that is just this angle plus this angle plus this angle. So we have added up all those three angles. Now this and this will get cancelled. So this angle is 180 minus theta. So we have a triangle C1, P, C2, and this angle is 180 minus theta. This is R1, this is R2, and this is the distance between the centers C1 and C2. If the circle equations are given to you, you can easily find the distance. Now let us apply cosine rule in this particular triangle. Cos theta is equals to R1 square plus R2 square minus D square divided by 2R1 R2. If you are asked to find out the acute angle between these two circles, you can just take the modulus. So this is the formula for angle between two circles. So now there is a special case. If the angle between two circles is 90 degrees, then we say the circles cut each other orthogonally. Okay. So if the circles are orthogonal to each other, then cos theta is 90 degrees and cos theta will be 0. So therefore, R1 square plus R2 square minus D square is equal to 0. So R1 square plus R2 square is equal to D square. Now let us say the equation of C1 is x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0, and the equation of the second circle is x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. Now r1 will be square root of g1 square plus f1 square minus c1 whole square plus r2 will be square root of g2 square plus f2 square minus c2 whole square is equals to d square. So d square is the distance between centers. The center of the circle is minus g1 comma minus minus g1 comma minus f1. The center of the other circle is minus g2 comma f2. Therefore the distance between the centers is g2 minus g1 whole square plus f2 minus f1 whole square. So since we have d square here, we'll square it. Now simplifying this, we'll get g1 square plus f1 square minus c1 plus g2 square plus f2 square minus c2 is equals to this inner part g2 minus g1 whole square. So which is g2 square plus g1 square minus 2g1 g2 plus f2 minus f1 whole square is f2 square plus f1 square minus 2 f1 f2. So this and all these quantities will get cancelled. So we will have minus c1 minus c2 is equals to minus 2g1 g2 minus 2 f1 f2. So 2g1 g2 plus 2 f1 f2 is equals to c1 plus c2. So this is the condition for the orthogonality of two circles. If two circles are orthogonal, they have to satisfy this particular condition. Alright, and this is the formula for the angle between two circles. Alright, now let us proceed. The next concept is radical axis. So what is a radical axis? A radical axis is the locus of a point which moves such that the lengths of tangents drawn from it to the two circles are equal. So let's say you have two circles, okay, and let us say there is a line. So if you choose any point on this line, the lengths of the tangents drawn from this point to the two circles, so this length and this length will be equal. So there might be another point which satisfies the same condition somewhere here. So if you collect all such points, it will form a line, and such a line is called as radical axis. We will prove that this locus is a line, straight line. Alright, so let us say this is the point P, and let us say this intersection point is A and this intersection point is B. Now according to our definition, PA should be equal to PB. Alright, according to our definition, PA should be is equals to PB. So since we are solving for locus, let us assume this point is H comma K. Alright, according to our definition, PA is equals to PB. So and we have to find the locus of P. So now what is PA? PA is simply length of the tangent drawn from an external point. So that is simply square root of S1, and this is simply square root of S2. Let us say this circle is S1 and this circle is S2. So this is S1, S2. Now this implies that S1 is equal to S2, and your S1 is simply h square plus k square plus 2g1h plus 2f1k plus c1. This is equal to h square plus k square plus 2g2h plus 2f2k plus c2. Alright, now these things will get cancelled. So now you will be left with 2 multiplied by g1 minus g2 h plus 2 multiplied by f1 minus f2 k plus c1 minus c2 is equal to 0. So this is the locus. So we got an equation in terms of h and k. Now replace h with x and k with y. So this will be your locus. Since this is a straight line, this is called as radical axis. So if you choose any point on this line and draw two tangents to these circles, so this tangent length will be equal to the length of the other tangent to another circle. Alright. So and now let us see few properties of radical axis. So now we got the equation of radical axis. So now this is the equation of the radical axis that we got. Let us say C1 is the center of the first circle and C2 is the center of second circle. So then C1 will have the coordinates minus G1 comma minus F1, and C2 will have minus G2 comma minus F2. Let us say this, let's find out the slope of C1 C2. Slope of C1 C2, that is the line joining the centers, the slope of this particular line. So that is simply G2 minus G1 upon F2 minus F1. Now let us find the slope of radical axis. Slope of radical axis, that is simply minus 2. So from this equation, line equation, you can find the slope, that is simply minus 2 G1 minus G2 upon F1 minus F2, or this can be written as minus 2 G2 minus G1 upon F2 minus F1. So let us say this slope is M1 and this slope is M2. If you multiply these two, M1 into M2 will be equals to minus 1. So the slopes are, the product of the slopes is minus 1. Therefore, the slope of this line, so therefore this line, which is the line joining the centers of the circle and the radical axis, are perpendicular to each other. Alright. Now that is the first property. We'll check one more property. Let us say there is some common tangent like this. Then this point P, let's say this point Q, it lies on the radical axis. By the definition of radical axis, this length, the tangent length, is equal to this tangent length. So you can say that the radical axis bisects the common tangent because it divides the common tangent into two equal halves. This holds good for the transverse common tangent also, not just the direct common tangent. It holds good for the transverse common tangent as well. Okay, I hope this is clear. So let us move ahead. So there are three cases. If the circles are touching each other, then the radical axis will be the common tangent, transverse common tangent. Alright, you can even prove it, just like how we proved this radical axis equation. You can consider two circles which are touching externally, and you can derive the conditions for these circles to touch externally. You can include those conditions while deriving for this equation of the radical axis, and you will find out that this is the radical axis. If two circles are intersecting each other, the radical axis will be the line passing through the points of intersections of the two circles. If the two circles are touching each other internally, the radical axis will be this particular common tangent. So now with this, we come to the end of this video. So from the next episode, which is the 7th episode, we will be only focusing on the problems related to circles. Alright. So if you like the content that I'm making, share the videos with your friends, subscribe the channel for more such content, and do not forget to like the videos. And if you have any queries about the concepts that I have explained in this video, please feel free to reach out to me in the comment section. Even if you have any generic queries, feel free to write them down in the comment section. I'll meet you in the next episode. Stay tuned. Take care.